Hello, Matt Davis here with more homework quiz help. This one comes from section 10.3. The hometown fans of a superstar baseball player feel that the player does not perform as well at the plate when there are runners on base. The data below shows the results of his at-bats this year cross-classified with the number of runners on base. At-bats resulting in a walk have been excluded. We wish to use the data to investigate whether or not the result of his at-bat is dependent on the number of runners on base. So you'll have done like a whole hypothesis test on this, and now what they want to know at the end is which of the cells provided the least evidence against HO, and choose your option from some given below, and it's multiple choice. But in reality, it shouldn't be multiple choice. Well, it is multiple choice, but it's multiple choice from this whole table. So like, what are we choosing from? From all these squares here, which there's 12 of them. And what we need is the mini z-score for each of those 12 scores. And then the one that is the largest provides the most evidence against HO, which is one version of this question, asks you for the most. And the one with the smallest mini z-score is going to be the one that gives you the least evidence against HO. So if you've already got all your mini z-scores, all you have to do is look at them and decide what's the smallest and the largest. I'll go ahead and show you the work on some mini z-scores and talk about the p-value a little bit here too to help you with some of the previous steps to this one. So what we're going to do is focus on just 3 squares. I'm not going to do them all, but I'm going to do this square right here, this square right here, and this one right here. And none of those were the ones listed in your multiple choice, so the real answer doesn't come from those 3, but I'm just going to do the work from those 3 and say, like, if, let's pretend those were the only 3 mini z's we had, then what would we choose for the most and the least? All right, so to make this work, we're going to have to start doing some of the kind of test stat work, which we would normally do like right within the table. But since I'm just doing 3 squares, I kind of pulled it off down here. So we want to look at the player makes an out when there's 3 runners on base. That was the upper right green square that I had there. A single with 0 runners on base, that's the 57 that I've shaded in green. Or that they get an extra base hit with 1 runner on base, which is that 20 I've got shaded in green. So that's the 25, 57, and 20 are just the observed frequencies from the table. So what we need now is expected frequencies for each one of those. So let's go ahead and start doing those. Let's see, maybe we'll color code it a little bit. So yellow right here, let's do the expected frequency for that one. So we go off to the side, and we're going to calculate E, which is going to be the row total and column total divided by the grand total. So for that 25, that's this row and this column. So the row total is 397 times the column total, which is 43, divided by the grand total, which is 608. And if you put that into the calculator, you get approximately, rounded to 2 decimal places, 28.08. And there's nothing tricky about that in the calculator. You don't need it parentheses or anything. You just type it as we wrote it, and it'll come out fine. So that first expected frequency is 28.08. All right, let's go ahead and keep using that same space over and over again, I think. So let's do the next one and fill that one in. So our next expected frequency is going to be for 57. And let's see, for the 57, I guess I'll just use a different color to mark this one. The 57 is here, and so we highlight that row and column that have the 57. So our row total is 137 times our column total for where the 57 is, which is 233. We divide that by the grand total on the table, which is 608. And if we put that one in the calculator and round it to 2 decimal places, we get 52.50. So that's what we would put here. And then we've got one more to go. So erasing that and going back. Let's see. I guess I'll have to do a different kind of highlighting here. So I'll highlight in red for the 20, which is right here. We want that row and that column. All right, so the row total there is 74. The column total there is 198. And if you divide that by the grand total of 608 and round that to 2 decimal places, which is the standard for expected frequencies, we get 24.10, and that 24.10 would be our last spot right here. All right, so that's where that comes from. All right, so that kind of helps you see how you do the values of E, but what we really need are those O minus E squared over E values. So, all right, so let's move on to calculating our mini z-scores. So we'll start out with this one for the player makes an out with 3 runners on base. So we're going to use this value of O and E to get the job done. So our mini z-score would be open parentheses O minus E. We have to square that and then divide it by the value of E, which is the decimal version there, so 28.08. So let's go do that one on the calculator, see what that looks like. So open parentheses, and then we're going to put the 25 minus the 28.08 and the parentheses, and then square to make sure the subtraction happens before the square, and then divide that by the value of E, which is the 28.08 number. And round that mini z-score to 3 decimal places. So 0.337, but the 7 followed by an 8, so we'll round up and go with 0.338. So 0.338. And then we could go and switch our values and use this O and this E to get the next one, and then use this O and this E to get the last one. Or we could do all 3 of them at once, which is what I would really like to do when you're doing all 12 of them, which is your reality. Put all 12 of your O's into L1, then put all 12 of your E's into L2, and then you can let L3 be O minus E squared divided by E, using L1 for the O and L2 for the E. So that will give us all 3 of them here at once. For you, it would give all 12 of them at once when you're doing the real problem. So let's go to the calculator, go to Stat, and Edit. And I've already entered in my 3 values of O and 3 values of E. Again, you would be using 12. Make sure that you're highlighting the title for L3, not down here in the first entry, but up top, highlighting the title. And then do your open parentheses, second L1, minus second L2, end parentheses. That gives you O minus E. Now you square that, O minus E squared, and divided by E, so divided by second L2. And when you do that, we get all 3 of them. So we get the 0.338 we already have, and then we get 0.386, rounding up because of the 7, and 0.698, rounding up because of the 5. So let's go copy those down. So in addition to the one we've already written, now we have 0.386 and 0.698. And again, which one is going to be what they wanted here, which is the least evidence against HO? It's whichever mini z-score is the smallest. So our smallest one would be right there. So that is the one that is the least evidence. And again, it's kind of 50-50 whether your question asks for the least evidence or the most evidence. If your question asks for the most evidence, you'd pick the largest mini z-score, which in this case would be the 0.698, and that would be the most evidence. Keep in mind, I'm only doing 3 squares here to show you the way the work looks. But for you, this is a decision you have to make from the entire table. So you'll have all of your mini z-scores, all 12 of them, and from all 12, you have to pick what is the smallest mini z-score, that's your least evidence, what's the largest mini z-score, that's the most evidence. That may seem like a lot of work, but it should be a natural part of doing one of these chi-square tests of independence that you list out all of your individual mini z-scores before you show the total. So they're all written down, and if you organize them correctly, then you can tell which one goes with which category. And so this question should be just a quick check back. Just a quick mention while we're here. When you do the p-value on this one, it is a little trickier than the previous section. For your DF, you need the number of row categories minus 1, and the number of column categories minus 1. So we do a double minus 1 subtraction here. So for our rows, we have 1, 2, 3 row categories. End up with that DF part here would be 3 minus 1. And then for the column part, we have 1, 2, 3, 4 column categories. So we're going to do a 4 minus 1 there. So we have 3 minus 1, 2 times 4 minus 1, which is 3. So 6 degrees of freedom when you do your p-value. So that's kind of a previous step. This question is mainly about this most and least evidence, but while we're here, we might as well get some extra practice with expected frequencies, with mini z-scores, and the DF part of the p-value. All right, I hope whatever was giving you trouble with this problem, this helps you out. Good luck to you as you head back to the quiz.